Hello, Marion. It's Mr. Lancaster. Welcome back. How's it going, guys? Let's get right back where we were. So our last question was whether or not our runny lava or the thick lava goes with the shield volcano, or does it go with the cone volcano like this? The shield was like this and the cone was like that. So which one did you think? You were supposed to write 2, 3 sentences and let me know and why you think that. So before you share your well, you can't share with it. Let me share my screen. Hold on one second. Keep forgetting to share my screen. Here we go. All right. So let me turn this on. Computer sound. So let's get right into this. Before let me tell you, we're gonna go here. Come down to this part. April 20th to now. Why do some volcanoes explode? We're gonna click right here. All right. We need to figure out where we were from last time.
Hi, it's
So we talked about this. We talked about how this is the one that doesn't explode. This is the one that does explode. That doesn't mean lava doesn't come out. This lava does come out. But this lava explodes really, really strong. So the experiment that they were going to do was you were going to have water like this, and then you're going to have more of like a thick, pasty kind. You can probably guess which one would be more runny. So if you took water and you had it on a hill like this, or like let's just say like the big volcano, not the shield but the cone, if you put water and you pour it on the top, what's gonna happen? The water's gonna come straight down like this, right? Now let's say you have this. I don't know what they mixed this with, to be honest, but obviously it's thicker. And what I actually would like you to think about instead is peanut butter, because peanut butter is thick and pasty, right? Everyone knows that, unless you, I can only think of one person who probably doesn't know about peanut butter because she can't get peanut butter. But she knows that if you take a jar of water, flip it over, it's going to come right out. It's really runny. Take peanut butter, flip it over, it's not going anywhere, right? If you take water and you put it here, it's going to run down. If you put peanut butter and put it here, is it going to run down? Maybe really slow, but it's going to take forever. Not like the water, right? So, Mr. Lancaster, how is this even going to tell me whether or not which one has the runny lava, which one has thick lava? Well, if you think about it, let's just say, how do volcanoes start in the first place? Well, they come up from the ground and then they start spewing out lava, right? So it used to be a flat ground, and then what happens? The ground breaks apart like this, and it comes apart. So when it comes apart like that, and there's a hole there. So what happens when holes come up? Things can come through them, right? So the best way to think about this is, let's say you're on a boat, okay? And the boat is like the crust of the earth. So this boat is holding you up, and you're not touching the water below. And let's say the water is magma, because water and magma are a lot alike. Magma is liquid and water is liquid. They both kind of run. So the boat, which is the crust, and you're sitting on top of it, what's going to happen if you drill a hole right in the middle of that boat? It goes like that. There's going to be a hole there, and then what's going to happen? Water's going to come up. You say, okay, so if water comes into your boat, it's going to splay out evenly, right? It's runny. So, but let's say if peanut butter came up in your boat for some weird reason. I don't know where you're swimming, but don't ask me. So, peanut butter comes up. Is it going to splay out real easy? Or is it going to just keep coming up and up and up and then globble around the hole? It's just going to come up where the hole is, and it's not going to go anywhere really, right? So, which one do you think would be the thick lava, and which one do you think would be the thin lava? Well, if I had to take a guess, I would say the thick lava is this, because before it splays all out like water, where it's nice and runny, it's already cooled off and now it's turned to rock. igneous rock. Remember our three rocks? Igneous, metamorphic, and sedimentary. So it's turned into igneous rock really quick, whereas this one, it's spread out more like water. But it's still not as thin as water. So before it gets out here, and then before it gets out, it starts to cool. So let's see what Doug has to say. Doug. Doug. All right, let's see if my sound's on.
So were you able to figure out anything about what kind of lava comes from each volcano? Which kind of volcano has the thin, runny kind of lava? The lava on the left there. Well, let's imagine a crack in the ground. And let's imagine that lava is shooting out of it. If that lava is thin and runny, it will flow nice and smoothly, and it will spread out into a big pile, just like in your experiment when you spooned your thin lava onto the plate. And doesn't the shape look familiar? Thin lava forms shield volcanoes. But imagine that the lava shooting out of the crack was thick and pasty instead. And because it's thick and pasty, it can't flow as easily when it comes out. So instead of spreading out, it will just kind of fall down into a pile. Splat. It piles up into a tall mountain shape, a cone. Look familiar? Thick lava forms cone volcanoes, just like it did in your experiment. So now you understand the differences between these two volcanoes. Shield volcanoes have a thin, runny lava that cools into a dark-colored basalt rock. And cone volcanoes have the thick, pasty lava that cools into the pale, felsite rock. But this only explains the shapes of the volcanoes. What we still don't know is why do cone volcanoes sometimes explode the way this one is doing here? The answer to this question is in the bubbles. Let me explain why we had you blow bubbles in your experiment. Inside a volcano is mostly melted liquid rock, but it sometimes also has gases in it, which make bubbles in the lava. So imagine you could look inside of a shield volcano, like this, which has thin lava. When bubbles form in thin lava, they travel up to the top pretty quickly, and they pop. You saw the same thing when you blew bubbles in thin lava in your experiment. Lots of bubbles reached the top really quickly. Plus, it was really easy to blow the bubbles. That's important to notice. The bubbles didn't have any trouble at all escaping the thin liquid and then popping at the top. But in thick lava, something different happens. Imagine we could look inside of a cone volcano now, which has thick lava. This is the kind of volcano that explodes, remember? This type of lava doesn't flow very well, and the thick and pasty lava tends to plug up the top of the volcano. It forms kind of a hard crust at the top. When bubbles form in this lava, watch what happens. It can't escape, and more bubbles will come, but they'll all get trapped at the top. The bubbles try to escape, but they can't, so pressure builds up, and this can go on for months, years, sometimes even hundreds of years, until one day the pressure is too great, and boom, the volcano explodes. You saw the same thing in your experiment. It was hard to blow bubbles in the thick lava. You couldn't even see the bubbles for a while.
So I used to do this when I was a kid. I used to get in trouble for it, but okay. So when I had like water, I would just go like blow the bubbles in it, and then the bubbles would come up pretty easy. And then I get some chocolate milk, and I do the same thing, and it was about the same. But then when my dad would take me to Sonic and I'd get a milkshake, I tried to do the same thing, and I took the top off and I did it, but it did not work out because I went and it didn't go at first. And I was like, what? And I went and it did it again and went right in my face, just like a volcano, just exploded right in my face. And this is just like that. So let's say this was like peanut butter again. With the water, I'm sure you already know you don't even have to do it, but if you want to, you can. With the water, it's going to be really easy just to blow a bubble and it's going to come right up. But with peanut butter, if you had peanut butter in a cup, you know how hard that'd be to blow air through it? That'd be ridiculously hard. So it's just like that thick lava. It's just so hard to get through. And that's when it starts building up and it's going to explode on itself.
All the bubbles were trapped under the surface until, boom, all the bubbles exploded out all at once. Bubbles in thick lava are the reason why the cone volcanoes explode. So we've solved the mystery. Let's look at that picture of Mount St. Helens again. Before it exploded, remember, and then after. So now we can understand. The thick lava inside the volcano trapped so many bubbles that the top and sides of the volcano eventually blew out, sending bits of hot rock everywhere. Now you may think that once a volcano like this has exploded, that's the end of its story, but it's not. In the time since 1980, since the eruption, Mount St. Helens has been slowly building itself back up again. Look at this. Do you see that? There's a little baby cone volcano forming right in the middle of the old explosion spot. It'll surely be a long time before the pressure inside this gets too great, but one day, Mount St. Helens will explode again.
All right, y'all. Well, that's the end of that. You should check out this video right here. I'm going to show you a little bit of it, but it's a really cool video. And this is a reading here. 1 second. It's also in Spanish if you want to practice your Espanol. But hot lava exploding into the cool ocean off Hawaii is drawing crowds. So the video is about this, and I'm also going to read about this next time. So you don't have to read this, but if you want to, please do. That'd be awesome. The more you read, the better. So I'm going to show this video real quick. Just the beginning of it. This is in Hawaii again. Kauai.
In the spring of 2002, Kilauea volcano on the big island of Hawaii began an eruptive episode now known as the Mother's Day flow. This activity is seen by Department of Interior U.S. Geological Survey scientists as a continuation of volcanism that began dramatically in 1983. Pu'u'o'o vent on Kilauea's East Rift Zone began spewing fountains of lava and building a...
Okay, I'm sorry, the name always gets me. Pu'u'o'o. So I'm going to stop this here, and if you want to check out the video, please do. All you have to do is go to my classroom, click on Why Do Some Volcanoes Explode, and it's going to take you here, and just go all the way to the end where the video is, and click on it. It's really awesome stuff. All right, guys, I will catch you later. I miss you so much. Have a good one. Bye.